Hello viewers, in today's class we are going to discuss one important problem from three-dimensional geometry, right? And here we'll take the concept of intercept form of plane, right? So let us first see the problem and then we'll solve these three parts one by one, right? So here we have the problem that a plane makes intercepts -6, 3, 4 respectively on the coordinate axis, right? So here the intercept made by the plane on coordinate axis are given, and we have to find the direction ratios of the normal to the plane and the equation of this plane which makes these intercepts, that is -6, 3 and 4 on the coordinate axis, right? And the second one is we have to find the length of the perpendicular drawn from the point -1 comma 2 comma 3 to this plane which makes these intercepts, right? And then we'll find the equation of a line which passes through this point, that is 4 comma -2 comma 1 and perpendicular to this plane, right? So let us solve these three parts one by one. So viewers, here we are given the length of the intercepts, right? So here we are given the intercepts -6, 3 and 4, right? So let us draw a rough diagram. Suppose we have a plane like this, right? And this plane makes intercepts on the coordinate axis as -6, 3 and 4, right? So let us take this intercept as A, this intercept as B, and this intercept as C, right? So we know that if a plane makes intercepts A, B, and C on the coordinate axis means this is the x-intercept, this is the y-intercept, and this is the z-intercept, then the equation of such a plane in intercept form is given by x over a plus y over b plus z over c is equal to 1, right? So this is the equation of a plane which makes intercepts of length a, b and c on the axis x, y and z axis, right? So now here the value of A is -6 and B is 3 and C is 4, right? So we can directly substitute the values here. So we'll get the equation of this plane, equation of the plane by x over -6 plus y over 3 plus z over 4 is equal to 1, right? So this is the required equation of this plane. Let us denote this plane by P, right? So now let us rearrange this equation by taking the LCM of 6, 3 and 4, right? So the LCM of 6, 3 and 4 is equal to 12, right? So now we can rewrite this equation as here we have 12 and here we have -2x, then we have 4y, then we have 3z is equal to 1, right? So we can now write -2x plus 4y plus 3z is equal to 12, and this equation can be written as -2x plus 4y plus 3z minus 12 is equal to 0, right? Now let us multiply both sides by -1, right? So we can now rewrite this equation as 2x because here we have minus and minus plus, here we have -4y minus 3z, and here we have 12, right? So this is the Cartesian equation of this plane P, right? So this is of the form that is ax plus by plus cz plus d is equal to 0, right? Because we know that any equation of first degree in x, y, and z of this type always represents a plane, right? So now let us rewrite this equation here. So we have 2x minus 4y minus 3z plus 12 is equal to 0, right? So this is the equation of this plane P. So here we have obtained the solution of this part, that is to find the equation of this plane P, which makes these intercepts minus 6, 3 and 4 on the coordinate axis. Now let us find out the direction ratios of the normal vector to this plane P, right? So the normal to this plane can be drawn like this, right? So we can write here the vector n. So this vector is the normal to this plane P, right? And we know that if we have the equation of the plane in this form, that is ax plus by plus cz plus d is equal to 0, then the coefficients of x, y, and z represents the direction ratios of this normal vector, right? So the direction ratios of the normal vector are given by a, b, and c, right? And if we compare this equation with this equation, then the value of a is 2 and b is minus 4 and c is minus 3, right? So these are the direction ratios of this normal vector. Now suppose we have to find the direction cosines of this normal vector, right? Then what we will do, we'll first find out this quantity, that is square root of the sum of the squares of direction ratios. That is 2 square, then we have minus 4 square, and then here we have minus 3 square. So this is square root of 4 plus 16 plus 9, that is the square root of 29, right? And then we divide these three numbers by this quantity to get the direction cosines of the normal vector n, right? So the direction cosines of this normal vector are given by 2 divided by square root of 29. Then we have minus 4 over square root of 29, and here we have minus 3 divided by square root of 29, right? So the direction cosines of this normal vector are given by these three numbers. So now in the second part, we have to find the length of the perpendicular drawn from the point minus 1, comma 2, comma 3 to this plane, right? So suppose here we have the point, say we can take this point as M, and the coordinates of this point are minus 1, 2 and 3, right? And suppose we draw a perpendicular like this, and we have to find the length of this perpendicular, right? So let us take this point as n, right? So what is the length of this perpendicular mn, right? So we know that the length of the perpendicular drawn from some point to the given plane is given by this formula, that is mod of say ax1 plus by1 plus cz1 plus d, and here we divide this quantity by square root of a square plus b square plus c square, right? So this is the formula for finding out the length of the perpendicular from a given point to the given plane, right? So here x1, y1, z1 are these numbers, right? So here the value of x1 is minus 1, then we have y1, that is 2, and z1 is 3, right? And the equation of the plane is 2x minus 4y minus 3z plus 12 is equal to 0. So the value of this capital A is 2, and capital B is minus 4, and capital C is minus 3, and D is 12, right? So now the length of the perpendicular MN is given by, here we have AX1, so we have 2x1 minus 4y1, then we have minus 3z1 plus 12, and divided by the square root of a square plus b square plus c square, and that is 2 square plus minus 4 square, and here we have minus 3 square, right? And now we can substitute the values of x1, y1, z1. So we have 2 times minus 1, then we have minus 4 times 2, then we have minus 3 times 3, and here we have 12, and divided by square root of this is 4 plus 16, 20, 20 plus 9 is 29, right? So this is the minus 2, minus 8, minus 9 plus 12 divided by square root of 29. So we have here mod of this is minus 19 plus 12. So this is minus 7, right? Divided by square root of 29. So we'll take the positive sign. So we have 7 divided by square root of 29, right? So the length of this perpendicular MN is given by 7 divided by square root of 29. Now let us take the third part. So here we have to find the equation of some line which passes through 4 comma minus 2 comma 1 and perpendicular to this plane, right? So here we can draw the diagram again. So here we have this plane P, and suppose we take a line like this which is perpendicular to this plane, right? And this line it passes through some point say 4 comma minus 2 comma 1, right? Okay, so now we see that the line this line, suppose this line is L, right? Now this line L is perpendicular to this plane P, right? And here we have the normal vector, right? So from vector algebra we know that if two vectors are parallel, then their direction ratios are proportional or equal, right? So the direction ratios of the normal vector are 2 comma minus 4 comma minus 3, right? So this line L has the direction ratios 2 comma minus 4 comma minus 3, right? So the direction ratios of the line L are same as the direction ratios of this normal vector, right? So here we have 2 minus 4 minus 3, right? And since this line L it passes through this point 4 comma minus 2 comma 1, then the equation of such a line can be written like this: x minus say x1 over a1, then y minus y1 over b1, and z minus z1 over c1, right? So this is the equation of any line which passes through x1 y1 z1, right? So here the point x1 y1 z1 is 4 comma minus 2 comma 1, and a1 b1 c1 are the direction ratios of this line L, right? So a1 is 2, b1 is minus 4, and c1 is minus 3, right? And x1 is 4, y1 is minus 2, and z1 is 1, because x1 y1 z1 represents the point through which the line passes, right? So we have x minus 4 divided by this point, this number 2. Then we have y minus y1 is minus 2, and here we have minus 4, and z minus z1 is 1, and here we have minus 3, right? So we can now write this equation as x minus 4 over 2 and y plus 2 over minus 4, and here we have z minus 1 over minus 3, right? So this is the equation of this line L, which is perpendicular to this plane P and parallel to this normal vector. So viewers, this is how we can solve this type of problem by making use of these concepts.